For example 3 in section 3.1, we're going to look at a graph here that they gave us. We could remind ourselves from the first two examples how this is an even degree, so we know the ends are going to go in the same direction, but it's also a negative out front, and so we know it's going to finish, if you will, at the very right. As x goes to infinity, y is going to also go to negative infinity. But some key points and some vocabulary to talk about. Turning points, as they're pointed out here, are these top two turnarounds and this bottom turnaround. We call these top two maximums or relative maximums, and we've estimated their coordinates here. A relative minimum is a turnaround, kind of like a bottom out. Notice though that it's not the most bottom or the farthest negative y value or lowest y value. The graph does continue to go down on the outsides, but we call this little turnaround more like a bubble, a relative minimum. You can use those vocabulary points when describing parts of the polynomial. For example 3, we recommend you skip part B and you actually also skip the try it, although you could graph that and look if it has any relative max or relative mins. Now, for example 4, we're going to try to sketch this. Remember back from topic 1 that when a graph is positive, it means it's above the x-axis, and when it's negative, it's below the x-axis. So when I come over here on the graph, it says it is positive between negative infinity and negative 4. So it's going to be up here between negative infinity and negative 4. Then it's going to go negative from negative 4 to negative 1. So it's going to go down here. But then it's going to go back positive from negative 1 to 4 and negative from 4 to 0. So I just drew these little sketches. Now that does mean that when it changes, we're going to have a change from being positive to negative. So that must mean it crosses the x-axis at 4 and negative 1 and negative 4. Those would be our x-intercepts. So notice how we can get some key features by just them telling us when the graph is positive and negative. Now we're going to talk about when the graph is increasing and decreasing. And remember, that has to do with the slope of the graph. So the function is decreasing from negative infinity to negative 2.67. So I'm going to go to negative 2.5 here. I'm just going to draw a line. I know the graph is decreasing like this, okay? And then it's also decreasing from 2 to infinity. So I'm going to draw a line here at 2, and from this point onward, it's going to go down. Okay, so I'll just draw my little arrows for now. But then I know it's increasing from negative 2.67 to 2. So in between here, the graph's going to go up. Now, this is where you just have to kind of piece together that you know it hits 0 at negative 4 and at negative 1. But it also goes from decreasing. So I'm going to have it decrease and hit 0. And then it's got to turn around here because it told us at this negative 2.67, it was decreasing. It's going to start increasing afterwards. So it must turn around there. Now, as I draw up here and I cross the x-axis, I know it's still increasing until it hits that 2. Remember, it was decreasing from 2 to infinity. So at 2, we have to start turning around here. And I'll do that and then cross back through that x-intercept at 4. If you look at your answer key, it kind of looks something like this, okay? My graph that I sketched isn't quite exactly like the one that this one has on the answer key, which I'll move right below, but it has those same features. So we're going to, it's a good enough answer. It doesn't have to be exactly spot on, but we do know where our max is located at 2 and at negative 2.67 for x values. And we can see that it's decreasing, then increasing, then decreasing with our x-intercepts 4, negative 1, and negative 4. We can mention all those things here, and you may want to check your answer key to be able to note those key points as well. And we do know that it is as x is going to x is going to a positive infinity. Let's start there. As x goes to positive infinity, our graph goes down towards negative infinity for the y value. But also as x goes backwards, as we travel x goes to negative infinity, the y values get higher and higher here. So we would say y goes to positive infinity. Now, because of our end behavior going in the opposite direction and finishing down towards negative infinity, we know this is an odd degree because they're going in the opposite direction, and we know that it would have a negative coefficient. because it finishes in the negative here. You'll start to see these patterns and be able to identify what type of polynomial it is just by some of those key features. And that's kind of mentioned here. You should try it on your own. Maybe try to make your own sketch. Remember, erasing is totally going to happen. Odd will tell you that the ends are going to go in the opposite directions. Remember, odd and opposite. The ends will go in the opposite directions. But the negative odd degree will end going down to the right. And by negative, we mean the negative coefficient, so the number out front before the highest odd degree. And just for your information, we are skipping example 5 and those triads.